Hi guys, I hope you're all well. Welcome to day 2 of solving conditional trig equations. And today we're going to be talking about solving double angles and triple angles as well. And again, we're going to keep in mind our domain for this entire unit is that x is going to be in between 0 and 2 pi, where 0 can be an answer because it's included in the domain, but 2 pi cannot. Be careful with that domain. Some of you guys were giving me answers of 2 pi on your homework from day 1. So just always keep the domain in mind as you're, giving me the angles and radians, okay? So last time we took a look at problems where we had to solve for, sine of x or, tan of x or whatever, where the angle was just 1x. Well, what happens now if we go around the circle more than one time, right? So 2x, 3x, however many times we want to go around the circle. So for example, if we have sine of 2x equals negative root 3 over 2, again, we're going to simplify that for ourselves, and we're going to do a substitution in for 2x, and we're going to say, let's let capital A equal 2x, let's say, okay? So then our equation becomes sine of A equals negative root 3 over 2. Well, now this goes back to what we did on day 1, where we're figuring out, okay, first of all, it's negative, so we got to figure out what quadrants we're in. So sine is going to be negative in quad 3 and quad 4. And then root 3 over 2, what does that remind you of? Well, that reminds me of my 30, 60, 90 triangle, so I'm going to draw that up. And which angle, when you take opposite over hypotenuse, which is sine, gives you root 3 over 2. That's going to be 60 degrees, which is pi over 3. Again, that's our reference angle. So that means that our A value, okay, is going to be pi over 3, but in quad 3, which is, so what is that? Pi plus pi over 3, which would give us 4 pi over 3. Okay, and in quad 4, that's going to be 6 pi over 3 minus pi over 3, which is 5 pi over 3. Okay, but what we need to understand about that is that right now, that's just one rotation of the circle. When you have a coefficient in front of the angle here, so like 2x, or you can see in the next example, we're going to do 3x, that number represents the number of times we spun around the circle. So when I get my initial answers here, those answers are just my answers within the first rotation of the circle. But what's happening here is this problem is saying, well, we went around the circle 2 times. So basically, not only is this an answer, but if I take 4 pi over 3 and then I spin around the circle one more time and land at the same spot that 4 pi over 3 is in, that angle is also an answer. So I would have to add 2 pi to this, okay, because that's one rotation of the circle. Same thing with this number. We're going to add 2 pi, okay? So when we do that, again, got to get a common denominator. So that's what? 6 pi over 3 plus 4 pi over 3, we get 10 pi over 3. Okay, and then 6 pi over 3 plus 5 pi over 3, that gives us 11 pi over 3. So these would be our answers within the second rotation of the circle. Okay, now it almost looks like we're done, except for, remember, what we just solved for is the variable a. But we don't want a, we want x. And remember, a was equivalent to 2x. So in order to solve for just x, you're going to consider it like it's, an algebra problem. We want to get rid of the 2, which means we want to multiply each one of these angles by 1/2 or divide by 2. So I'm going to multiply each angle by 1/2. So 4 pi over 3 times 1/2, that's going to be 4 pi over 6, but I'm going to reduce that down to 2 pi over 3. Same thing here. This is going to give me 5 pi over 6, 10 pi over 6, which reduces down to 5 pi over 3, and 11 pi over 6. Okay, and there you go. all of these are your answers for this particular problem, and then you're done. So now let's try the same thing again, but we're going to do it with tan of 3x equals 1. So I'll do the same strategy where I'm going to let a equal 3x. So I get tan of a equals 1. Okay, and again, this is where tangent is positive. So if you look at Smart Trig class, that would be quads 1 and 3. And I know the ratio of 1 reminds me of my 45, 45, 90 triangle, which means my reference angle is pi over 4. Okay, so that means that A in the first quadrant is just pi over 4. And then in the third quadrant is going to be 5 pi over 4. And again, that's within the first rotation of the circle. But how many rotations do we have? We have 3 of them total. So in order to get the second rotation, I'm going to add 2 pi to each of these answers, which will give me, what is that, 8 pi over 4 plus 1 pi over 4. That's 9 pi over 4. And then 8 pi plus 5 pi gives me 13 pi over 4. Those are my answers in my second rotation. But again, for this problem, we went around 3 times. So I got to add 2 pi to these angles now to get the last rotation. Okay, which will give me 8 plus 9 is 17 pi over 4. And then 8 plus 13 gives me 21 pi over 4. Sorry, I'm squishing it here. 21 pi over 4. But again, remember all of these are equal to a, not to x, which was equal to 3x. So if I divide both sides by 3, that's the same thing as multiplying by 1/3. So my answers for x are going to be pi over 12, 5 pi over 12, 9 pi over 12, which can be reduced down to 3 pi over 4, 13 pi over 12, 17 pi over 12, and then lastly 21 pi over 12, which can be reduced down to, 7 pi over 4. So if it can reduce, I would want you guys to reduce. And then all of these answers would be our answers for number 2. Okay, so now let's move on to another example. Example 3 might be a good one where if you guys want to pause the video and try it on your own, you can certainly do that. But if I were to go about this problem, what I would do first is I would subtract over this cosine 2x, just so it's on the same side of the equation. So we get cosine 2x sine x minus cosine 2x equals 0. And now the cosine 2x's become a GCF. I'm going to factor it out. I'm left with sine x minus 1 equals 0. So you got 2 separate equations, cosine 2x equals 0 and sine x equals 1. Okay, and this cosine 2x, again, this is an example where we might want to let a equal 2x. So you get where cosine a equals 0. Well, if it's equal to 0, that means we have to be on the axis. Remember, the ratio for cosine is x over r, so it's where x is 0, which is going to be on your y-axis. So that means that a is going to initially be pi over 2 and 3 pi over 2. But we have 2 rotations, so that's just the first rotation. So to those guys, I'm going to add 2 pi to each one of them to get the second rotation. So 4 pi over 2 plus 1 pi over 2 is 5 pi over 2. And 4 pi over 2 plus 3 pi over 2 is 7 pi over 2. That's your second rotation. And again, we're not solving for a, we're solving for x. So this is equivalent to 2x. So we have to divide everything by 2 or multiply everything by half. So our answers for x will be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. But we also can't forget to solve for this. This is where sine x equals 1. And sine x equals 1, again, that means you have to be on the axis there because there's no triangle where the hypotenuse and the side will be 1 over 1. So it's where y is 1, which is going to be up here, which is at pi over 2. Okay, so that's also an answer. So x equals pi over 2 is an answer, as well as all of these from before. Okay, so moving along to number 4. So this is kind of just going back to like a normal type of problem because our angles are just like 1x. So this doesn't really have to do with double angle or triple angles, but it's a good exercise to review from day 1. So we're given sine x plus 2 equals 3 cosecant x. And again, not great to have like two different trig functions here. But remember, cosecant in the numerator is the same thing as sine in the denominator. So I'm going to rewrite this equation as sine x plus 2 equals 3 divided by sine x, because that's really the same thing. And then in order to clear the fraction, I'm going to multiply everything through by sine of x. So we get sine squared x plus 2 sine x equals 3. And then you might notice that this is actually a quadratic. Sorry. This is actually a quadratic, so I'm going to get it set equal to 0 by subtracting the 3 over. So I get sine squared x plus 2 sine x minus 3 equals 0, and then I'm going to try to factor that normally, which it does. It factors into sine x minus 1 and sine x plus 3. So we would get that sine x equals 1 and sine x equals negative 3. Again, because it's out of the bounds of sine, this is not doable. So this guy over here would give us no solution. And where sine x equals 1, well, we just did that in the last example, right? We know that's going to be up at pi over 2. Now, one thing I do want to mention that I forgot to mention last time is that when you guys are going through and doing these problems, if the problem involves a trig function with a denominator, which would include tan and cotan, right? Because those can be written as sine x over cosine x or cosine x over sine x. Secant and cosecant, basically. So basically all the trig functions except for sine and cosine themselves. You have to go through and double check your answers to make sure that it doesn't make the original equation undefined, right? So for example, here I'm getting where sine x equals 1, that's going to be at pi over 2. However, that's going to be an answer that I want to double check because in my original, I'm given cosecant of x, which is the same thing as 3 over sine of x. So long as the answer that I get down here doesn't make this denominator 0, then I'm fine, which I know it doesn't because I would just solve for when sine x equals 1. So again, double check whenever you have denominators in your original, which is basically anytime you have a trig function other than sine or cosine in the original, you have to check your answers to make sure none of the denominators of those trig functions are becoming 0 and actually wouldn't work to begin with. So that's just an added note that I want to make sure you guys understand. Okay. And then this last problem here says 5 cosine squared x plus 3 cosine x equals 0. So if we try and factor that, you should notice that there's a GCF of cosine x. We're going to take that out. And we're left with 5 cosine x plus 3 equals 0. So that means that that's when cosine x equals 0 or when cosine x equals negative 3/5. And so cosine x is going to equal 0 on your y-axis here. So that would be at x equals pi over 2 and 3 pi over 2. So those are easy to get. But cosine x equals -3/5 is a little tougher because, again, we don't recognize the ratio of 3/5 as either coming from our 45-45-90 triangle or our 30-60-90 triangle. So we first take care of the negative by determining what quadrants we're in, a smart trig class. So cosine is going to be negative in quad 2 and 3. And then if you remember here, we need to use the calculator for this. I realized the last time I tried to show you guys the calculator, it didn't show up, so I apologize for that. So I'm just going to kind of voice through it. But once I kind of play around with the program and I figure out how to allow the calculator to appear, I will definitely include it in my videos. But just remember that when you go to take inverse cosine, make sure your calculator's in radian mode. And when you go to inverse cosine, you are not including the negative here, right? The negative just told us that we're in quads 2 and 3. But when I actually go to do it in the calculator, I'm just doing inverse cosine of positive 3/5. So I'm going to switch over to my calculator here. And again, I know you can't see this, but I'll sort of voice through what you should be typing in. And so when you go through again, just double check that you are in radian mode, and you want to hit second cosine of positive 3/5. Okay, and that should give you a decimal about 0.927-ish, hopefully. And remember, that's giving us our answer in quad 1. So because I'm concerned about quad 2 and quad 3, I'm going to store that as x. And then in quad 2, we have to do pi minus x. So that should give me an answer of 2.214. And then in quad 3, we have to do pi plus x. And that should give us an answer of 4.069 if we're rounding to 3 decimal places. So again, those answers were x equals 2.214 for quad 2 and x equals 4.069 for quad 3. Again, another thing I might want to do to be extra analytical and vigilant here is that I might want to ask myself, is this a problem that I have to double check my answers for? Well, because my original was all in terms of cosine, the answer is no. If I had a cotan in there, or secant in there, some type of trig function that originates from a denominator, then I would want to check my answers. But in this case, we don't have to, so we know these are correct, and we're all done. So hopefully that will help you guys complete part 2 homework from worksheet 1, which I believe is numbers 12 through 25. And, we'll kind of go from there. All right, have a great day, guys. Bye.